Hey everyone, we are OpenGraph and we are super excited to share what we've been built for the AI Agent Hackathon. So OpenGraph is a fully on-chain AI, handling everything from the verified models to inference, data processing, and the storage, 100% on-chain. So let's start from the why we are building this. So we believe that the AI processes need to be more verifiable and auditable, and this is where it all begins. So in the era of the autonomous AI agents, where the agents they independently make the decisions across the multiple domains, actually is fast approaching. And in such a future, transparency isn't just nice to have; it's an essential thing. So verifiability and auditability are the cornerstones that ensure the AI actions are not only effective but also trustworthy. So new AI agents are emerging every day. Right now, we are still testing their purposes and figuring out their optimal use cases. But imagine a time when these AI agents are granted the autonomy to make decisions that directly impact our lives. Trust become the paramount. So with the traditional Web2 systems, API calls just don't cut it for massive trust. But blockchain here, however, offers an ideal solution by making every step fully transparent and verifiable. So based on these demands for the trust and transparency, we decide to showcase a comprehensive end-to-end AI process that happens entirely on-chain. So from the data input to model deployment to inference, and nothing is here left off-chain. So here we found that the Sui blockchain is a perfect match for end-to-end on-chain execution for AI. So it's first off, it's a fast and has really low gas fees, which means that you get amazing scalability and transparency and also the efficiency. So of course, uploading the huge data training and test data sets directly on chain would be not practical, but here is why we rely on the Walrus, a fully decentralized storage solution that keeps every bit of the data secure and on-chain. So with Sui handling the rapid and low-cost inference and Walrus here from the data storage to modern executions is completely on-chain, auditable and verifiable. So this is a whole architecture we are imagining. We want to prove the digital the provenance of the data access and AI model for the AI agents. So now let's take a look at how it all works. So we actually split the entire process into three parts. So first we created the move library called TensorflowSui, which is an SDK designed to help the publish models on chain. So and then here we took for example as an example, we took a traditional MNIST model from the Web2. So this model is about reads and infers handwritten numbers. And once we upload the graph file using our SDK, people can just simply convert and publish their model on chain onto the Sui blockchain. So this process here generates the package ID and automatically stores the training and data sets on Walrus. And with this inference ready status, model is already now on chain. We can start executing the inference. We've also optimized the process by splitting the transaction to reduce some gas fees. So this called PTB. So these are the overall steps that we will go through. And now I want to show you guys how it actually look like through our demo. So let's play the demo here. So let's begin at the terminal. So we kick things off by running TensorflowSui directly on from our GitHub repository, and it helps to set. This is SDK, so it helps the people to upload their Web2 model, and we convert this into the things. We convert them to help them to deploy on chain. So using our SDK, we just publish its JSON file on chain. So here, after putting here, the model was published on chain, so it's already live on the Sui network, and the training data set here for the model is now secured, stored in the Walrus. So here we can see the package ID is generated, and you can verify the transaction on the Sui scanner. So let's say once we click this link, we can redirect to the C scanner where we can check out our what was that, package ID. And also we can see the block data on the Walrus. So here, Walrus, on the Walrus scan, we can see the block ID. So, and also we can also check out the object, which refers to the deployed model here on the SUI scanner as well. So now let's move on to the inference part. So now the model is ready and is ready to inference. So we were going to start the inference process on our on-chain model by loading the input data here from the Walrus. So let's say I want to input the digit 6 from our test data set, and here you can see we got the result. I mean, here we already put the input here. So during the inference is in progress right now. So the process is split into 16 transaction plus 1 PTB, I mean the programmable transaction block, which makes the multiple comments into a single transaction, and this will be our final transaction. So making a total of 17 transactions. You can see the gas uses for each steps, and overall it only took about 0.053 to get the inference readers. So we have 17 transactions happen, and finally the gas use as a let's say at the bottom here we can see the total gas use. So and the model version is now automatically updated on the Walrus as well. And if you check the transaction details, you will notice that both input and output are recorded here. So here you can check out the events. And yeah, so this is the total whole process about how we build the end-to-end on-chain executions on Sui network with using Walrus as a storage. And furthermore, we also experimented with integrating the Atomas API, which uses the LLM model, so Llama v3. So we asked the LLM to describe what a handwritten number should look like. And as you can see from here, um, yeah, as you can see from here, it accurately picked the right output from our Walrus testnet. So yeah, this is our demo. You can explore more on GitHub under TensorflowSui. So let's back to our main slides here. So yeah, so this is a quick note about the Atoma that was mentioned in the demo. So we use the LLM here, and Atoma actually enables us to run a large-scale LLM model on-chain, while us, like OpenGraph, makes the end-to-end on-chain execution feasible for more smaller models. So by strategically balancing this trade-off, we believe this approach achieves the optimal balance in the Web3, and this is all powered by the Sui network. So yes, overall, we studied all of this, but with a clear mission and belief that AI agents need to be verifiable on the blockchain, to be truly usable at an industrial level. So that's why we moved the entire AI process on chain, creating an end-to-end decentralized application. So by leveraging the Swiss blockchain and its native wallet storage, we built a kind of fully integrated on-chain AI executions. Okay, so that is everything from our side. So thank you for listening and hope you guys enjoyed it. Thank you.